Okay, welcome everybody. Today we're going to look at dimensional analysis and we're going to do a few examples. Now, just as a precursor, dimensional analysis is a way of looking at the relationship between different units of measure. In this case, we're going to look at how units from the metric system can be converted into units in the customary system, which is what we use here in the United States. It should be pointed out here that the US actually does use more and more metric units in science, medicine, technology, sometimes even in the military. So we do have a need to be able to convert from one unit to the other. Now this method is going to involve using fractions. And what we do is we make a fraction that has equal values in the numerator and the denominator. And so that what we're doing essentially is multiplying our measurement by a value of 1. When you multiply something by 1, you don't actually change its value, but by making these fractions with different units in them, we can convert one unit to the other and end up with our conversion. So I think an example will help out here. So we're going to use the Grand DeLorean as our example here. It says every morning the Grand DeLorean wakes up and heads to the gym to work out. He warms up by bench pressing 580.0 pounds. How many kilograms of mass is this? Yes, the Grand DeLorean likes to get swole. So here's our conversion factor. 1 kilogram is equal to 2.20 pounds. So what we can do, step one, real easy here, is you can just make two fractions out of this. You can make one fraction that's 2.20 pounds over 1 kilogram. Since these are equal measures, this equals that, the value of this fraction is 1. Or we can use 1 kilogram over 2.20 pounds. I'm actually just going to write LB and leave the S off there. Now, which do we use? Let's find out. So we're starting with 580 pounds. So we're going to write 580.0 pound. We're going to write the unit. We're going to make sure we write our unit. And we're going to turn that into a fraction by placing it over 1. Okay? Now, if your teacher is pressing you for significant figures, right now this has 4 significant figures. We don't worry about the 1 under the fraction in the denominator. That's not going to factor into this. That has an unlimited number of significant figures. So right now we're dealing with 4, and we're going to multiply this by another fraction whose value is 1, and we can pick from these 2 fractions here. Now, what we want to do is we want to pick one that has the old unit that we started in, pounds, on the bottom. The only way pounds will cancel out is if pounds are on the bottom on this side. So we're going to want to use this fraction down here, 1 kilogram over 2.2 pounds. So we'll put that in there, 1 kilogram, 2.20 pounds. Now this one has 3 significant figures, and this one has 4. So our answer should be in 3 significant figures. The 1 kilogram, we'll just think of that as like a whole unit. We're saying that if you had exactly 1 kilogram, this is what the pound equivalent would be. So these ones really have an unlimited number of significant digits. So we're going to do a 3 on this one, 4 on this one. So our answer needs to be in 3 because that's our smallest number of significant digits. So we can cross cancel already. Pounds are going to cancel out because pounds divided by pounds is 1. So we end up with 580.0 times 1 kilogram equals 580.0 kilograms. And then 1 times 2.20 is 2.20. So what's our answer? Well, take our calculator, and when you're doing fractions like this in the calculator, you take the top and divide it by the bottom. So we'll do 580. The calculator works better when it's turned on. Little things I've learned. 580 divided by 2.20, and we get this big number. Now, we said our answer has to be in 3 significant figures because that's what we had down here. So we're only going to use the first 3 significant figures. We've got 263, and then we've got 0.6. So we're going to round that up to 264. And then the unit is kilograms. So 580 pounds, 264 kilograms. That's how we do that doing dimensional analysis. Now let's look at another example. All right, now in this example, the Grand DeLorean needs 200 cubic yards of concrete. I don't know what he's building, but he needs a lot of concrete. But he's ordering from a company that only measures in cubic meters. How many cubic meters is 200 cubic yards? And the conversion rate is 1 meter equals 1.09 yards. So again, make two fractions. 1 meter over 1.09 yards, or 1.09 yards over 1 meter. Both of these fractions equal 1, but which one are we going to use? Let's have a look here. So we've got 200.0 yards cubed, and we'll put that over 1. So we've got 4 significant figures here. Now, which one are we going to use? Well, we want to have the yards on the bottom to cancel out. So we're going to use this one. 1 meter over 1.09 yards. Again, we've got 3 significant figures here now. So we're only going to have our answer in 3 significant figures. So what's the problem here? The problem here is that when you cancel out 1 yard here, that's only going to cancel out 1 yard here and actually leave us with yards squared. So if we did our math right now, we'd have 200 times 1 meter, 200 yards squared times 1 meter. We would end up with 200 yards squared meters, which that doesn't make any sense. So we need to get 2 more yards out of there. The only way to do that is to convert this 2 more times. 1 meter over 1.09 yards times 1 meter over 1.09 yards. Now, these 2 yards will cancel out these 2 yards. And now when you look at it, you've got 200 times 1 meter, which is 200 meters, times 1 meter, which is 200 meters squared, times 1 meter, which is 200 cubic meters. And that's going to be over 1 times 1.09 times 1.09 times 1.09, which is going to be around 1.3. Let's have a look here. We'll take our calculator, which is still on, thank goodness, 1.09, raise it to the 3rd power, and we get 1.2950. So we're going to go with 1.3. Oh, we've got 3 significant figures, so we can go to, that's still going to be 1.3. So we're going to go with 1.3. Now, is there a shortcut for this? Absolutely. Let's just rewrite this one time. 200.0 yards cubed over 1 times. Now, what if we just cube this? We just raise these both to the 3rd power. You would get 1 meter cubed, that's what all this is, over 1.3 yards cubed. That's what that is. So you can like kind of take a little shortcut here, just cube the conversion factor. And the reason you have to cube it is because in cubic measures, you know, you've got a length, a width, and a height on something to make it 3 dimensions like that. So you have to factor in, you have to convert for this measurement, and this measurement all at once. So cube it, cubic yards, cancels out cubic yards. 200 times 1 is 200.0 meters cubed over 1.3. We'll do our math in our calculator. Of course, again, top divided by bottom. 200 divided by 1.3 gives us 153.8. Now we're going to go to 3 significant figures, so we're just going to go with 154 meters cubed, because that's our unit right there. All right, let's look at one more example. So anybody who's been in my class knows the Grand DeLorean loves running Disney races down there. Actually, I don't love the races so much as I love eating around Epcot when I'm done and putting all those calories right back on. So half marathon, he runs 10 feet every second. How many kilometers per hour is this? So we've got a couple things going on. One, we've got a unit in feet per second, and we want it in kilometers per hour. So we've got a couple conversions that have to happen here. So first thing we'll do is we will write 10 feet, and we're gonna write it like this: 10 feet per means it's a fraction, 1 second, okay? And now we're gonna multiply this. First thing we'll do is we'll do the 5,280 feet is 1 mile. And so we're gonna make our fraction here. And we know from the last two examples, feet need to be on the bottom because feet are on the top here. So feet need to be down here so that they cancel out. So the 5,280 feet will go on the bottom, and the 1 mile, we're gonna do MI, because M is meters. So MI for miles, and we're gonna cancel out our feet. So now we're in miles per second. All right, we need to be in kilometers per hour. So let's do the kilometer one next. The reason I write all this out this way, I've seen students do this before. They look at all the conversions and they just figure it's either multiplication or division, and they divide everything and they get the wrong answer. If you write it out, it'll tell you when you have to multiply and when you have to divide. So right now, this is a division problem, 10 divided by 5,280, but let's see what happens with the time here, or kilometers. So we're gonna go fraction. We want miles to cancel out, so the miles part has to go on the bottom. So we're gonna go 0.62 miles is 1 kilometer. So this fraction's worth 1, this fraction's worth 1 because these are equal distances. Miles will cancel out. Now we're in kilometers per second, and we need to get this into hours. So 2 ways to do this. One, you can do, you've got seconds on the bottom, so you can put 60 seconds on the top and 1 minute down here. And then you could do another one where you put 60 minutes up here and 1 hour down here, and that will all cancel out. Let's just take a little shortcut, and let's just go seconds to hours. So we're gonna put 1 hour on the bottom here because that's what we want to end up in, kilometers per hour. And how many seconds are in 1 hour? Well, there's 60 seconds in a minute, and there's 60 minutes in an hour. So 60 times 60 is 3,600 seconds in 1 hour. Cross those out. Now we're ready to do math. Oh, look at this. We're going to be 10 times 3,600. Then we're going to be divided by 5,280 times 0.62. So you have both multiplication and division in this conversion. And by writing it all out, just taking a couple extra seconds to write it all out will keep you straight on which one you're doing. So 10 times 1 is 10, times 1 kilometer is 10 kilometers, times 3,600 is 36,000 kilometers, over, you got 1 times 5,280, which is 5,280, 5,280 times 0.62. Let's go to the calculator for this one. 5,280 times 0.62 is 3,273. 3,273.6. And that's hours. So there's our answer, unit, kilometers per hour. Now we just got to do 36,000 divided by 3,000. So 36,000 divided by 3,273.6, and we end up with 10.997. So we're going to go with 11. And we wanted to have, well, there's 2 significant figures. Really the conversion factors, though. Yeah, we're going to go with 11 because it's 10.99. So we're going to go with 11 kilometers per hour of running. That's how many kilometers per hour that is. So we had to do multiple conversions. We just line them up. Then we multiply the tops, multiply the bottoms, do our division at the end, and arrive at an answer. I hope this video helped you. Please email, or if you're one of my students, talk to me in class during goal time or something, and we can keep going over these problems. And I hope you have a good rest of your day, and I'll see you next time.